Okay, so this is core paper 1, so only watch this video if you sat the core paper. So you'll notice because the questions will be different anyway. So question 28 is the first physics question. A solid metal block has a mass of 2 times 10 to the 4 kilograms and a volume of 2.5 meters cubed. What is the density? So density is mass divided by volume. So you're going to do 2 times 10 to the 4 divided by 2.5. And you get a value of 8,000, giving you C. Okay, so you just need to make sure that you're rearranging your equations correctly. Okay, 29, you've got P and Q pulling on a rope. Team P pulls with a force of 500 newtons to the left, Q 800 newtons to the right. This is clearly larger than this one. Okay, so the force to the right is the larger one, so the resultant is going to be to the right hand side. The difference is obviously 800 minus 500 is 300 newtons. They are pulling to the right with 300 newtons more effort than this lot. Okay, question 30. A liquid starts to evaporate. So if we think about what evaporation is, if we have a liquid in a beaker, evaporation is where molecules that are on the surface have enough energy to escape. Okay, that is not the same as boiling. Boiling is when it happens in the whole liquid. It can happen from the bottom. That's why you see all the bubbles in boiling. But with evaporation, we don't see the bubbles because it's only gas at the surface that leaves. So, firstly, they have to have enough energy to go from being a liquid to a gas. So it's definitely going to be the more energetic ones that can escape, getting rid of A and B. Okay, so we're not interested in those. And then we have to think about what happens to the temperature of the liquid that's left behind. Okay, so the high energy molecules escape, okay, leaving what's left behind as the lower energy molecules. Okay, lower energy, less vibration of those molecules is a lower temperature. Okay, so it cools it down. This makes sense. Think about when you are trying to cool your body down, you sweat, which means that the sweat evaporates off your skin. Taking that energy away, it cools you down. Okay, C. 31 is looking at convection. So we've got a hot water tank is fitted with 2 identical heaters, P and Q. So they do the same job. But P is above heater Q. The tank is full of cold water. When only heater Q is switched on down here, it takes a really long time. So think about what happens in a convection current. Okay, so if we have our heat source at the bottom, if we think about just a Bunsen burner for a minute, and we've got a beaker of liquid, the molecules close to the Bunsen burner start to vibrate more, and they have their density reduced because of that, because they take up more space. Okay, so they move up, and the more dense, colder molecules move down into the space. Okay, so you get this convection current set up. So we know that with heater Q, it has to set up the convection current, throughout the whole heater. That's a huge amount of space. Okay, so it's going to take a long time to get all of the temperature up to the right temperature. Then it says what happens to the cold water when only heater P is switched on. Now we know that if we have a liquid, which is what we've got, we get a convection current set up. But we know that the hot water molecules, the increased temperature water molecules, will move up. But the heater's here, okay, so we've got our molecules over here. These ones at the bottom start to vibrate more and they move up. But it's only the ones above that can fall back down to take the space. Okay, and so what happens is the water at the top all starts to heat up, but the heater doesn't have a big effect on the temperature of the water below because the convection current will cause the heat to rise, not to sink. Okay, so we know that we've got all of that energy now being directed at a much smaller amount of water above, and so the water above heater P will now reach that 60 degrees in a much shorter time, because that same amount of energy is being used to heat up much less water. 32 is one just that you need to remember. So the number of crests on the surface of water that pass a particular point each second. So if we sketch out the surface of that water wave, we know that this is the crest point. Okay, and if we have a point in space that we are stood at and the wave is travelling in this direction, the number of these crests that pass a point per second is the frequency. Okay, we've got to remember the definitions there. Okay, 33 is the focal point. Okay, the principal focus is another way of saying focal point, the point where all of the light rays focus together, they meet. That is point C, so that's just one to remember there. And another wave question. We've got an amplitude of a sound wave increasing and the frequency decreasing. So I'm going to draw my original wave like this, and now I'm going to increase my amplitude and decrease my frequency. It's going to go off the page. Okay, but you will see that my amplitude has increased and my frequency has decreased. Okay, less waves happen per second because it takes longer on the time axis for that wave. Okay, so the amplitude has gone up, the frequency has gone down. Apologies, I can't finish that off because I've run out of page. So we have to think about what happens to the loudness and what happens to the pitch. Loudness is linked to amplitude, so if the amplitude goes up, loudness goes up. So I can get rid of C and D. Okay. If the frequency is now a smaller number, it's now going to be lower pitched. The more squashed up the waves are, so if I've got one that looks like this, that's going to be very high pitched, whereas one that looks like this is going to be lower pitched. Okay, it's more spread out, so that gives me B. Okay, next one is an electricity one, so 35. We need to find the resistance of the lamp. We just use V equals I times R. Rearrange to get R is V divided by I. I'm told that the voltage from the cells is 6 volts over here, so I put 6, and the ammeter reading, which is current, is 2. 6 over 2 is 3 ohms, gives me B. Okay, 36 is about parallel resistors. So we've got 2 connected in parallel. So I'll sketch it out first. It looks like this. I've got a 1 ohm and a 2 ohm resistor. I know for resistors in parallel that 1 over R total is 1 over R1 plus 1 over R2. Okay, so that's equal to 1 over 1 plus 1 over 2. Okay, so that's clearly 1 plus a half is 1.5. Okay, that's 1 over R total. I can rearrange that so I can see that R total is equal to 1 over 1.5. And that gives me a value of 0.67 ohms, which is less than 1 ohm, which gives me A. Okay, 37 is about a fuse. So the fuse is just a small piece of metal that gets put inside of a circuit, and if the current that flows in is too high, the metal wire, which is really thin, melts. Okay, and so what you then end up having, if you imagine this in your circuit, is something that snaps, because if it melts, it breaks. And so if you think about what that does to the rest of the circuit, it stops there being a complete circuit and it no longer works. The current is no longer there, it goes to zero. Okay, 38 then is atomic physics. You've got a decay curve. You can see the count rate changing, and it asks you to find the half-life. So the first thing we do is we look at time 0 and we find out what the initial count rate was. Each 2 squares is 100. Okay, so initially that is 2,200, sorry. Okay, so at t equals 0, count rate was 2,000, can't spell today. Goodness me, sorry, my writing is shocking. 2,200. So we know that after one half-life, later, this count rate has to half. So I'm looking for when C is 1,100. Okay, and that occurs here. So when I track across, you can clearly see that that is at 2 days. Okay, so my answer is 2 days. 39. How many nucleons does this nuclide contain? That is not neutron, okay? Nucleon equals the number of protons plus neutrons. So therefore I need the sum total, so I'm looking for the mass number. So I look for the biggest number. That's protons and neutrons, so it's 16. And then last but not least, quite a simple one to finish off, you've got, if it wants to go focused for me, the model of the atom. The central bit is obviously the nucleus, where you've got your protons and neutrons, and we know that electrons orbit around the outside. So the central bit is obviously the nucleus getting rid of A and B, and I know that it is an electron, which gives me D.